All right, in the previous video, we looked at examples of polynomial functions, but we never really went over actual examples. We looked at kind of what are the possibilities, but we never looked at any concrete graphs, and we never looked at any concrete equations that had the numbers in there. And so what we're going to take is, in this video, is we're going to apply the techniques that we talked about in the previous one to actual examples. Okay, so now let's talk about key points, features of polynomial functions, how to find them. We're going to start off with the basics, the stuff that we should already know. And so just like with any other type of function that we look at, one of the key things that we always want to find is intercepts. And so when we talk about y-intercept, this is where the graph crosses the y-axis. It is equal to the constant term in the polynomial if it's written in descending order with no parentheses, which that's what we're going to be looking at here. But in general, remember that to find the y-intercept, we plug in 0 for x, and we simplify the expression. The second thing that we have is x-intercepts. Remember that x-intercepts is where the graph crosses the x-axis. And I'm going to say crosses or touches the x-axis. In order to find x-intercepts, algebraically, we want to use a combination of factoring, quadratic formula, square root property, in order to find the x-intercepts. Now, a lot of the problems that we're going to look at in this particular section, we're mostly going to be focusing on graphs and equations. We're not going to spend a whole lot of time finding x-intercepts algebraically. We'll do a little bit of it in the next section. In future sections and courses, we will discuss other techniques that can be used to find x-intercepts, including, and these are going to be presented in the pre-calculus course, something called the rational zeros theorem and long or synthetic division. All right, we can also do this graphically. And graphically, what we can do is use the calculate 0 on our calculator in order to find these if they are not nice. In the previous video, we talked about turning points. And so remember, turning points, this is where the graph changes from increasing to decreasing and vice versa. Algebraically, this is not something we can compute at the moment. This is one of the fundamental topics in calculus. But in this course, and we're not really going to focus on it, but in this course, you can do it graphically using a graphing calculator. And what we want to do is calculate maximum or minimum using our calculator. The last thing I want to mention is something that is, we are not going to spend any time on it in this class, is we have something referred to as an inflection point. Okay, so this is not a high priority topic, but this is just to kind of let you know that it is something that will be introduced later on in future math classes, and you probably won't actually talk about it until you get to calculus. And an inflection point is just one beyond the turning point. Turning point is where we go from increasing to decreasing and vice versa. Inflection point, this is where the graph changes from something we call concave up, which looks like a cup, to concave down, which looks like an umbrella. I'll point out kind of these points when we look at some examples, but note that we cannot do this. This is something that cannot be computed algebraically and is, again, one of the fundamental topics in calculus. Same thing graphically. It cannot be computed graphically. It's something that will be discussed in future math classes. All right, so now we're going to take what we've talked about And we're going to go ahead and apply it to specific examples, including graphs and equations. All right, so for each one of these graphs, we're going to go ahead and identify the things that we talked about in the previous section. So we want to figure out the turning points. How many turning points do we have? We want to estimate the x-intercepts. We want to state whether the leading coefficient is positive or negative. And we want to determine the minimum degree of the function. All right, let's go ahead and look at our first example. All right, so we want turning points. I'm going to label that TP. All right, so turning points, remember, is where is the graph switching from increasing to decreasing or vice versa. And so when we look at this, going from left to right, we are increasing until we get to this highest point, and then we're decreasing. And so we only have one turning point. All right, the next thing that we want is we want to estimate the x-intercepts. And so for our x-intercepts, I can never get this to be the right size. Okay, x-intercepts. All right, I have an x-intercept here at 1, 0. And remember that we want to write these in point form. And then I also have one here, and it looks to be about halfway between -2 and -4. And so I'm going to estimate this as -3, 0. All right, we want to know the leading coefficient. Is it positive or negative? This is going to be negative. And the reason that this is negative is this is opening down. And it is a even degree polynomial. And so because we are opening down and down, this tells me negative leading coefficient. And the last thing that we want to know is what is the minimum degree? Well, remember that degree can equal or has to do with x-intercepts. We have 2 x-intercepts, and we have 1 turning point. And the one that we do want to focus on is both of them tell us that our minimum degree is 2. We have 2 x-intercepts. And remember that the number of turning points is always 1 less than the degree. Okay? And so that's what we have for here. We have our minimum degree is going to be 2. All right, let's go ahead and look at a couple more. Let's come over to the second one. All right, we want to start by finding turning points. And so how many turning points do we have? All right, when we go ahead and look at this graph, from left to right, we see that we are starting at the very top. We are coming down. We are then turning around and going back up. This is our first turning point. All right, we go up, and then when we get up to this point, we turn around and we come back down. And so we have a total of 2 turning points. All right. The next thing we want is, what are the x-intercepts? And so for x-intercepts, we have 3 x-intercepts. We have one at -2, 0. We have one at 0, 0. And we have one at 2, 0. We want to know, is the leading coefficient positive or negative? And so here, because we do have our in behavior is up and then down, this is going to be a negative leading coefficient. And the last thing that we want is minimum degree. And so because we do have 3 x-intercepts, 2 turning points, my minimum degree is going to be 3. Another thing, I do want to kind of just revisit some of the other topics that we've talked about so far, is this is an odd function. Not just odd degree function, this is an actual odd function. Notice here that when we look at our points, we have -2, 0 and 2, 0. If we look at these other ones here, we have -1, -3, and we have a 0.13. And so notice that, especially these last 2 that I put up here, is notice that when we look at these 2 points, I change the sign of my x, I change the sign of my y, and they're exact opposites of each other. We also have that our graph, granted this isn't always the case, but notice here that our graph does go through the origin. Okay, so not only is this a degree 3 polynomial, it is a odd polynomial. All right, let's go ahead and look at a couple other ones. All right, let's come down to this one here. Okay, let's see what we have. We want to know how many turning points to start off with. All right, so when we go from left to right, we are decreasing. We come down to this valley, and then we turn around and we increase. We come up to the top of this peak, and we decrease. And again, we get down to the valley, and we turn back around, and we go back up. And so for this, we have 1, 2, 3 turning points. All right, we want to estimate the x-intercepts. And so we have an x-intercept here at -4, 0. We have one here at -2, 0. We have an x-intercept at 2, 0. And we have an x-intercept at 3, 0. Okay. All right, I want to know leading coefficient. Is it positive or negative? Well, because my in behavior, I do have up and up, my leading coefficient is going to be positive. And finally, we want to know minimum degree. Okay, we have 4 x-intercepts, 3 turning points, and so that means that we should have a minimum degree of 4. All right, let's keep going. We've got a couple more to look at. All right, let's look at this one. Okay. Now, so far, all of the graphs that we've looked at, we can tell the minimum degree based on the number of x-intercepts. Now, remember that x-intercepts is not the best indicator, and this is going to be the first one that we see where that happens. So, we're going to start with turning points. In order to figure out our turning points, we're going to go ahead and figure out where is this increasing and decreasing. So our graph, we are starting at the bottom and we are going up. I did that in the wrong color, didn't I? Okay, we're going up. We get to the top, we come back down. And then we turn around and we go back up. And so when we look at turning points here, we have 1, 2. All right, we want to estimate the x-intercepts. And so for this, we only have one x-intercept, and it is at -3, 0. We want to know leading coefficient. Is it positive or negative? Because we do have an end behavior of down and then up, my leading coefficient is positive. And then we want to look at the minimum degree. Okay, so for minimum degree on this, we only have one x-intercept. But remember that we don't want to use x-intercepts to determine the degree for this, because if it's one x-intercept, then you have a degree of 1, and that should be a linear function, and I think we can all agree this is not linear. And so when we look at minimum degree, especially when we start having these turning points that never actually get down to the x-axis, that's what we need to look at. We need to look at turning points. Because I have 2 turning points, my minimum degree is going to be 2 plus 1. Remember that turning points is 1 less than the degree. And so my minimum degree for this one is going to be a degree 3. Now, though we're not going to really focus on this topic, okay, it will come up in later math classes, is that whenever you have a situation like this, we go up, we come back down, but we never touch the x-axis, but then we have these turning points that never cross the x-axis. What's actually happening when we see these points is this is where we have those non-real complex solutions. Just think about our quadratic. Whenever we had that it did not touch the x-axis or cross the x-axis, remember that that thing was not factorable. And if we did quadratic formula, then what we got was non-real. We had things in terms of i's. And that extends to all of our other polynomials. Whenever we have these turning points that don't actually go all the way down to the x-axis, we have a pair of non-real complex zeros. All right, let's look at a couple more examples. All right, the next one we're going to look at is going to be this one. And it does all sorts of crazy stuff. Okay, but let's see what we got here. All right, we want to start with is turning points. All right, so our turning points. We're going to go ahead and figure out what we're doing. All right, so from left to right, we are coming down. We get to this bottom point in the area, and then we turn around and we go back up. We go down. We turn around and we go back up. And then we turn around and we go back down. Okay, so when we look at these transitions from increasing to decreasing and decreasing to increasing, we have 1, 2, 3, 4. And so we have 4 turning points. All right, we also want x-intercepts. So what do we have for our x-intercepts? We have -2, 0. We have -1, 0. We have 0, 0. 2, 0. Sorry, that last one was supposed to be 1, 0. One 0 and 2, 0. Okay. All right, we also want our leading coefficient, because we are going up and then down. This is going to be a negative leading coefficient. All right, and we want minimum degree. Okay, so if we look at this, we have 5 x-intercepts. We have 4 turning points. And so my minimum degree is going to be 5. If you look at this graph, this actually is also another example of an odd polynomial. Not odd degree, but odd polynomial. If we notice the points that we do have here, this one, I can't get my thing to do what I want. Okay, this one here, we are looking at about 0.5, 1.5. I'm sorry, negative 0.5, 1.5. And down here, this is positive 0.5, negative 1.5. We change the signs. But everything else is the same thing. Same thing over here. If we look at this point, this is pretty much the same position away from the origin. And so this is another example of an odd polynomial. All right, let's go one more. Okay, last one for these ones. Okay, we want to know how many turning points do we have. All right, if we go ahead and figure out turning points, I have a turning point here where I'm going from decreasing to increasing. I have a turning point here. I get to this tiny little hill before I turn back around and go down. We get down to this lower point, and then we hike up our trail to the top of this peak before we head downhill again. And so this one we have 4 turning points. All right, we want x-intercepts. X-intercepts, we have a total of 3. This point is also an x-intercept, so we have an x-intercept at -1, 0. We have a x-intercept at 0, 0. And we have an x-intercept at 1, 0. We want to know the sign of our leading coefficient. And our leading coefficient, we look at our in behavior. We have up and then down, which means that my leading coefficient is negative. And finally, we want to know minimum degree. Okay, we have 3 x-intercepts, but we have 4 turning points. And so it's not possible to have remember that turning points is always going to be less than the degree. And so here we are going to go ahead and use the fact that we have 4 turning points to identify our minimum degree. And our minimum degree is going to be 5. It's going to be 1 more than the number of turning points. All right, so this is playing around with graphs and identifying these things. The next thing that we're going to do is we are going to look at equations and then use the equations to kind of pick. We're going to have a multiple choice of graphs. All right, now we're going to go ahead and start with equations, and then we're going to go ahead and try to figure out the key features, and then we're going to match it to the graphs that I'm going to show you in a few minutes. Now for all of these equations, the first thing that I do want to do is I want to write it in descending order so that we can go ahead and identify our leading term a little easier. So for example A, I'm going to rewrite this as x squared minus 2x plus 1. We have our terms in descending order. We've got 2, 1, 0, and so this is what we have. All right, so let's see what we got here. We have a degree is 2. We have a leading coefficient that is positive. And so remember that the combination of these two things tell me that my graph is going to open up and up. The other thing that the degree tells me is I have, for my x-intercepts, I have possibly 0, 1, or 2. And the last thing it tells us is turning points. Because my degree is 2, we are going to subtract 1, and that means that I have at most 1 turning point. And actually, we'll have exactly 1 turning point. All right, we're going to go ahead and do the rest of the equations first, and then we'll go ahead and look at our graphs. All right, let's come to example B. Example B, Again, I'm going to start by rewriting this in descending order. We want to make sure that we keep the sign with its term, and so my minus x cubed, I'm just going to move it to the front. My positive 3x, I'm going to move it to the back. All right, for this one, we have a degree of 3. This is our largest exponent. We have a leading coefficient. That is negative. And so remember, if it's an odd degree and a negative coefficient, then we are going to be going up on the left and down on the right. We also have number of x-intercepts. So my x-intercepts, it's not possible to have 0 x-intercepts, but it is possible to have 1, 2, or 3 x-intercepts. And the reason it's not possible to have no x-intercepts is because we are going up forever, we are going down forever, we're going to have to cross the x-axis at some point. We also have turning points. And so for this, we're going to have a max of 2 turning points. We take our degree, we subtract 1, and that's giving us a max of 2 turning points. All right, let's come to example C. All right, example C. We have a cubic. It's in the correct order. And so my degree is going to be 3. My leading coefficient is positive. And so what these two things tell me is that we are going to go down on the left, up on the right. For our x-intercepts, again, we can have 1, 2, or 3 x-intercepts. And for our turning points, we will have a max of 2. We take our degree, we subtract 1, and that's the most number of turning points that we can have. All right, 3 more. Let's see what we got. All right, when we come to example D, it is in the correct order. We have a degree of 4. We have a leading coefficient that is positive. And because it is an even degree and a positive coefficient, then I know that it's going to look something like this. We are getting pretty large here. I'm going to say maximum of 4 x-intercepts. We can still have 0, but it can be any number between 0 and 4, since our degree is 4. And for our turning points, we take our degree, we subtract 1, and we get a maximum of 3 turning points. All right, 2 more. All right, if we look at example E, I'm going to flip this around. I want my largest exponent first. This becomes negative x to the 4th plus 8x squared. we have a degree of 4. We have a leading coefficient that is negative. And so that means that my graph is going to go down on both sides. We have a maximum of 4, and turning point, we're going to have a max of 3. Okay. 4 x-intercepts because our degree is 4. Again, that's the maximum we can have. We take our degree, we subtract 1, and that tells us our maximum number of turning points. All right, and last one. Now, you may sit there and think this is going to be the hardest one just because we got fractions running around. But just remember, we're really only looking at this leading term. And so the rest of the numbers really don't affect this at all. So what we have is we have a degree of 5. Our leading coefficient is positive. And because my degree is odd and my leading coefficient is positive, I know it's going to go down on the left and up on the right. For our x-intercepts, we have a maximum of 5. Because it is a degree 5 polynomial, we can have at most 5 x-intercepts. And turning points, we subtract 1 from the degree, and we get a maximum of 4 turning points. All right, so now that we have all of that information there, we can go ahead and identify each one of these graphs. Okay, so the first one's the only one that is quadratic, and so we all know what quadratics look like. If we look at this one here, we notice that we have a degree of 2. We have a up and up in behavior. We do have 1 x-intercept, and we do have 1 turning point. All right, for B, we have a cubic polynomial. And so my cubic polynomials are going to be either the top middle graph or the top right graph. Example B is going to be the top right graph. It is the one that has a end behavior of up on the left and down on the right. It has 2 turning points, and we do have 3 x-intercepts. That means that the top middle graph is going to be C. We have a leading coefficient that is positive. We have an end behavior of down on the left and up on the right. We have 3 x-intercepts, and we have 2 turning points. All right, examples D and E, these are both 4th degree polynomials. And so example D is going to be the bottom right. It is the one that has an end behavior of up and up. It does have less than 3 x-intercepts, but it does have, it does have less than 4 x-intercepts. It's at 3, but we do have 3 turning points. And so the 3 turning points is the thing that really tells us that this is a degree 4 polynomial. Example E is going to be the top left graph. We have our end behavior of down and down. We have less than 4 x-intercepts. We have 3 of them. And we do have 3 turning points. And while that leaves that, our final example, the bottom middle graph is going to be the graph of equation f. We do have our end behavior is down on the left, up on the right. If we count our x-intercepts, we have 4, which is less than 5. That's allowed. And we do have 4 turning points. Now, for those of you who have graphing calculators, you're probably sitting there thinking, okay, well, why can't I just plug it into my calculator? And I'm just going to go ahead and say what most math teachers say, even though it's really stupid, is, well, what if, we have the apocalypse and your graphing calculator no longer works? Okay, well, that's kind of a stupid reason, because at that point, you're probably thinking, I really don't care at all. But when you think about historically, what did people do before we had graphing calculators? This is all stuff that can be done without a graphing calculator in order to get a general idea of what it looks like. Now, of course, we've talked about, the end behavior, the leading coefficient. We've talked about the turning points and how many x-intercepts. And as you get higher in math, you can find these things without the use of a graphing calculator. You get into using techniques that will allow you to find all of these key points by hand. All right, that takes care of this section. And so we will go ahead and continue our discussion of polynomials in the next section. See you again soon.